Okay, so here we go. To multiply matrices, right? First you have to check the dimensions. Remember how to add and subtract matrices, you have to check the dimensions? Well, it's the same thing for this one. Suppose you have to multiply A by matrix B, okay? What you do is you look at the dimensions of matrix A, and suppose matrix A has dimensions 3 by 2, and matrix B has dimensions 2 by 4. In order for you to be able to multiply them, these inner numbers have to be equal to each other. That's how you know you can multiply the matrices. And once you've established that you can multiply the matrices, the outer numbers give you the dimensions of the new matrix. Okay, 3 by 4. All right, so let's try to see what I mean by that. Take a look at this. I have one matrix times another matrix. What are the dimensions of the first matrix?
3 by 2.
3 by 2. And the second one? 2 by 4. Because these are the same, you can multiply them. All right? And then the new matrix will have dimensions 3 by 4. Okay? So the one thing that is different between multiplying matrices as opposed to numbers, when you multiply two numbers together, 3 times 5, you just get another number that looks the same. When you multiply matrices together, you might get a matrix that looks completely different, and that's okay. All right, what about the other one? You have a 2 by 3 and a 2 by 2, and can you multiply them? No. Because these are not the same, you can't multiply them. All right? Okay. One other thing that's different in matrices from numbers is with numbers, multiplication is cumulative. So for example, 3 times 5 or 5 times 3 are the same. It's not like that with matrices. If you have A times B, that's not the same as B times A. Okay, so you have to make sure to keep the order. Okay, so order is important. Okay, now on the next page, we're going to multiply these matrices. And the first time I do it, you see I do it in a lot of detail. But it's never going to take you this long to multiply matrices. Once we get through the first one, we're going to do them in a much shorter way. Okay, so we're going to multiply A times B. Okay, let's first figure out what the dimensions of the new matrix are going to be. So here I have a 2 by 3, and here I have a 3 by 2. So what's going to be the dimensions of the new matrix? A 2 by 2. So the dimensions of AB is going to be 2 by 2. Cool? Okay, so in order to start multiplying, what you do is you create a matrix that's 2 by 2. And I like to put in the slots where the answers are going to go. So that's what my new matrix is going to look like. Okay? And I have a blank one here. This is what my new matrix is going to look like. All right. In order to multiply, here's what you do. So suppose first I want to get the answer that goes in that space, right? What's the position of that space? It's 1, 1, row 1, column 1. So in my matrix here, I take row 1 and column 1, right? So look, row 1 here and column 1 there. Okay? Row 1 of the first matrix, column 1 of the second matrix. How many elements are in row 1? How many in column 1? 3, right? They have to be matching. If you do it properly, they're always going to match. Okay, now what you do is you multiply each of the corresponding numbers and add the results. So for example, multiply the first one by the first one, okay, plus the second by the second, negative 3 times 5, plus the third by the third. Okay? That's the one for row 1, column 1. All right. Next, down here, we're going to move on to the next element. Now we're going to do this one. What position is that? Row 1, column 2. So I take row 1, column 2. So at each step, I say to myself, which position am I going to fill? Row 1, column 2. And I take row 1, column 2. And same thing. The way I do it, look up here for a minute. Look up here for a minute. Here's how I do it. I multiply corresponding terms. So the first ones, second ones, third ones. First, second, third. So the first term, it's going to be what times what? 2 times negative 4. Plus negative 3 times 1. Plus, what's the last one? 1 times negative 2. Okay. Next, I'm going to take the next one, right? So this one. This is row 2, column 1. So I take row 2 with column 1. And I multiply them. 5 times negative 3 plus 0 times 5 plus negative 2 times 6. Okay. Lastly, row 2, column 2. Okay. So 5 times negative 4 plus 0 times 1 plus negative 2 times negative 2. Okay. Now that you've filled them all in, all that's left is the addition or subtraction, right? So let's see what the product is. All right. This first one here, what does that give us? Negative 6 minus 15 plus 6, negative 15. Right? Okay, what about the next one? Over. Negative 8 minus 3 minus 2, negative 13. This one here, negative 15, 0, negative 12, negative 27. And the last one here, negative 20, 0, positive 4, negative 16. Okay? And that's how we multiply the matrices. Now, a lot of times, students will just do this in their head. So for them, they'll say, okay, negative 20, 0, positive 4, negative 16. Right? Like, you're not going to have to write it out like this every single time. Okay? All right, so let's do one here. So let's find AB and BA, right? So let's do AB. AB, always write them down so you know the order. Okay, what are the dimensions here? 2 by 3, 3 by 2. We can multiply them, right? And what's the result going to look like? What dimensions? 2 by 2. Okay, so let's start. Row 1, column 1. I take row 1, column 1. This is the most important part, because if you take the wrong ones, then it doesn't work. And always make sure you have the equal number in each of them. Okay, so look at what we're going to do. We're going to multiply these out. Okay, the first ones, look, they give you negative 4, 0, 27. Okay, so negative 4, 0, 27. Okay, what about the one next to it? Row 1, column 2. Right? Okay, so tell me the numbers. First one is 0 plus what? Plus 9. Okay, next. Row 2, column 1. Okay, tell me the numbers. 10, 7, 9. And then the last one, what was this one? 0. So it's 0, minus 14, and 3. Huh? No? Yeah, did I not? So, 0, yeah. Yeah, that's why I like to circle them, but I know it's hard. So this. So 0, negative 14, 3. So finally, I get 23, 9, 26, negative 11. Okay? Honestly, the only part is like make sure you're taking, like the correct rows and stuff. Okay? All right. Well, what about BA? Huh? Well, let's see. I think it is actually because we get 2, negative 1, 9. This is 3 by 2. Negative 2, 0, 3. This is a 2 by 3. Okay, so it does work. What's the result going to be? A 3 by 3. Okay, so let's come up with a way that you can keep track without, having to erase too much. So first one, we're going to do row 1, column 1. So that's row 1, column 1. Okay? So it's going to be negative 4, positive 0. Positive 0, plus 0. Okay? Row 1, column 2. I'll just switch my arrow to the next one. So tell me, what do we get? 0 and 0, right? Try to follow with your pencil. So 0, 0. And then the last one, row 1, column 3, 6, 0. Yeah? Yes or no? Okay, why don't I give you a few minutes to fill in the rest? Okay, so I'll give you 3 to 4 minutes. Do this one, the second row, and the third row. So we'll see. Okay, so let's take this one. Okay, because look, you don't have to go in order. You can be a rebel and go in different order, just take random ones. But if you take that highlighted one, what position is that? This is row 2, column 2, right? So I'm going to take row 2 with column 2. It's so important to get the rows and columns straight. Row 2 and column 2. Then you take the first numbers in each circle. Negative 1 and 0 multiplies to 0. 2 and negative 7 multiplies to negative 14. Okay? All right, so this will give us negative 4, 0, 6, 12, negative 14, negative 1, negative 3, negative 21, 30. Okay, so take a look. Positive 27. and positive 3. This one?
No, the middle one.
This one?
Oh, sorry, it's 7 here.
Yeah.
Sorry.
Okay, so take a look. We did A times B, and then we did B times A, and look at how completely different the answers are, right? So again, it's not commutative. It's not like 5 times 2 and 2 times 5. All right, so let's do this next one. This is kind of interesting. So A times B is negative 2, 1, 3 times 4, negative 6, 5. Okay, dimensions of the first one? 1 by 3. And this one? 3 times 1. So what's the product going to be? A 1 by 1. You're just going to have one row and one column. Okay? So that's what it's going to look like, a 1 by 1. So this term, we can still call it row 1, column 1. That means I take row 1 with column 1. That's all I got. So negative 8, negative 6, 15 is just a 1. Okay? So that's still a matrix. It needs its bracket, but it's just 1 in there. Okay? All right. Let's do BA. Yeah. I'll just write BA first. Oh, okay. So we have, So we have a 3 by 1 and a 1 by 3. We're going to get a 3 by 3. Okay? All right, so take a look at how this one works. This first one is row 1, column 1, right? So row 1, column 1. You just have one number to multiply, negative 8. Okay? Next, row 1, column 2, 4. Next, row 1, column 3, 12. Okay? All right, so I'll give you like 2 minutes to go ahead and do the other 2 rows, and then we're going to continue. Put it away. All right.
6, negative 18.
And the last row?
Negative 10, 5, 15.
Awesome.
Now it's frozen.
Oh, sorry. Okay. All right. So that's matrix multiplication. Not too bad. Okay. Let's move on to the next page, to inverses and determinants. All right. A determinant is a scalar. A scalar is basically like a regular number, not a matrix. A determinant is it's a scalar number that is unique to a specific matrix, right? Every matrix has its own determinant. It's like a characteristic of a matrix. Just like each one of you have like a different characteristic, that's what a determinant is. Okay, notation. Pay attention, guys. Notation. To write the determinant of a matrix, suppose this is matrix A. In order to write determinant, there are 3 ways that we can show determinant. One is this, one is this, and one is that. So the bars, the vertical bars, they're no longer absolute values in matrices. They become determinants. Okay? So if I say A in vertical bars, it means the determinant of A, and then the other one is the determinant of that matrix. All right, so how do you find determinant? It's very, very straightforward. If you have a matrix A, B, C, D, you take this. Remember how that was the main diagonal? You take that and you multiply it, so it's A times D, minus, always minus, the other diagonal, B times C. And that's it. Okay? Now, some trivia for you. A matrix whose determinant is 0 is called singular. It's a singular matrix. So if you're ever on Jeopardy and that comes up, you now know. You got to give me on-air credit, though. Huh?
Did you do math
Always. I mean, I love those categories. I have not. I used to never miss it. Then I had kids and then, yeah.
You should go on Jeopardy.
Oh my gosh, I don't know about that. It would just have to be, yeah, math and science. Yeah. Yeah.
Dr. Marcus should go on Jeopardy.
He should. He really should.
He would know everything.
Okay, so.
We should tell him.
Okay, determinant of this matrix, right? 1 times 3 minus negative 2 times 4. And honestly, the only issue I've seen students have is negatives. Usually, it's just negative. No, it means determinant. In the world of matrices, it means determinant. So if you look in the box above, that's what we're just talking about. So determinant of A is 3 plus 12, 15. That's it. Pretty easy, right? Huh? Oh, so it's 11. Ah, so negatives were not the only mistakes. Matrix. So let's talk about numbers. Back in the day, you learned this term, multiplicative inverse of a number is 1 over the number. Okay? What does that mean? Suppose I give you the number 5. What can you multiply that with in order to get a 1? 1/5. Okay? That means that number 1/5 is the multiplicative inverse of 5. So an inverse is something you can multiply something with in order to get a 1. All right? Well, that's what we're going to find now for matrices. Okay. So take a look. Notation for inverse of a matrix. Hey, look up here. We have a little bit more to go. Notation for the inverse of a matrix is A inverse. That's how we read it. It's not A to the minus 1, it's A inverse, or inverse of A. Okay, how do we find the inverse of a 2 by 2 matrix? Step 1, find the determinant. We just learned how to do that. Okay, that's a number. Step 2, you gotta change the matrix. The way in which you change the matrix is this. You see A and D there, the main diagonal? You interchange their positions. It's like they change seats. They switch seats, okay? And then you add negatives in front of the other two, right? So swap the highlighted one.
Or positive.
Right, you switch the sign of the other one, okay? So swap, change sign. Then step 3, multiply the new matrix by 1 over the determinant, okay? So that's how it looks. Let's try one. Okay, to find the determinant, remember there are multiple notations for it. We're going to do this, which is positive 40, minus 40, that's equal to what? 0. Okay, but guess what? That's a singular matrix. It has no inverse. Okay? It has a determinant. It's 0. That's fine. It just has no inverse.
Are there any other methods?
No. It's just a special case when it's 0. Okay, so here, let's find determinant. It's negative 12 minus, okay, look, this is a trick I do. I put the minus first, then I go and I find the other product so I don't get mixed up with the negatives. Yeah?
If the determinant was 1, the inverse just being 1?
It'll be, well, no, you still change the matrix, but it'll be 1 over 1 times that.
Oh, okay.
Yeah. Okay, so A inverse is going to be 1 over this number 4. Okay? And then in the new matrix, this diagonal, they change spots. So 6 and negative 2. Oops. Yeah. The other ones, their signs change. So negative 4, positive 4. Okay? And then, lastly, you have to distribute this. So this becomes 6 over 4, negative 4 over 4, 4 over 4, negative 2 over 4. So finally, A inverse is 3 over 2, negative 1, 1, negative a half. Okay? Yeah, this is where we're going to stop today.